This is the Phase 4 Ground Weekly Report for the week ending September 11th, 2016. Some of us are going to be at GNU Radio Conference all of next week and Tapper DCC next weekend. There will be very good opportunities to meet up at both events. Check in with Mike Springer, W4UOO, at Tapper. He's holding down the fort at DCC, like base in a game of tag. If you are at GRC or DCC, please feel free to post whatever seems relevant and interesting to Phase 4 on the GNU RadioCon 2016 and Tapper DCC 2016 channels in our Slack. That's what I'll be doing. I will do my best to summarize at the end of the day on the email list in a single post. First up, Lime SDR unboxing and call for developers. Steve Conklin applied for and won one of 2 Lime SDRs. The description of Phase 4 Ground was compelling enough, and the Lime SDR shipped out to Steve last week. Here's a video.
All right, we have 2 boxes here from Lime Microsystems for the Phase 4 project. Let's see what's in them. The first one is a small black box with a Lime SDR board in it. I won't remove it from the static packaging, but there's the board. And the second box Lime SDR acrylic case. So I'll go to the lab and I'll put the board in the case, and then we'll figure out what we're going to use this for on the Phase 4 project. And here we have the finished unit in the acrylic case. Nice rubber feet, 4 SMA connectors, and an attractive case. We'll put this to work soon.
Steve is willing to coordinate and advise a team to figure out how to make the Lime SDR work for us. Now, the Lime SDR has a maximum frequency range of 3.8 gigahertz. However, there is an upcoming LMS 8001 add-on module which will extend Lime SDR coverage all the way up to 12 gigahertz. With an RF bandwidth of 61 megahertz, 12-bit sampling depth, and a 61 megahertz sampling rate, 2 transmitters, 2 receivers, full duplex, USB 3.0, and 40,000 gates of programmable logic, excellent oscillator precision. It looks highly promising. You can see from this chart that the Lime SDR is very much a contender with all the other SDRs we've been using and talking about. There's also Scilab's EVM progress. Dr. MPEG, also known as Ron Economos, W6RZ, generously agreed to test an evaluation module, or EVM, for a Scilab's DVB chip. The chip in question is the SI2169. Links to Scilab's web pages about it in the notes. The EVM is big and beautiful. Here's his setup. There's a transport stream file at the correct bit rate, which is given to a GNU radio flow graph running the DVB-S2X transmitter, which goes to a USRP B210 SDR, and then out a coax cable with a 30 dB attenuator, and then off to the Silicon Labs EVM, then to a USB to an old laptop, then to the Silicon Labs GUI, then UDP to 127.0.0.1, and then VLC, just copying UDP to 10.0.1.190, a Linux workstation, and then decode with VLC on a Linux workstation. Okay, well, if you followed all that, great. Ron was able to confirm the correct operation of the DVB-S2X portion of the GNU radio transmitter. Up till now, it was untested. Only the DVB-S2 portion had been tested, not the extension. That's the X. This is a big step forward for GNU radio, and therefore a big step forward for us. He was also able to record video content from the IEEE 1394 port of his cable TV box. He has a transport stream multiplexer that can redo the stream to the exact required bit rate for a specific symbol rate constellation. Now, this transport stream mux is work-related, so it's not open source. A key quote from him is, "It's too bad because it's way better than anything out there, like FFmpeg or VLC. Hey guys, opportunities. The only thing that remains untested is the VLSNR portion of the DVB-S2X transmitter, which, as you recall, Ron added a couple of weeks ago to the GNU Radio project. Ron also did some DVB-T2 testing with the EVM. It seems a little buggy in DVB-T2 mode. Some profiles he knows that work were confusing it. His evaluation is just because the EVM acts weird with DVB-T2 doesn't necessarily mean there's a silicon issue. More likely it's just the EVM software. Steve Hicks, N5AC, was instrumental in getting the loan of this EVM board to Phase 4. He handled the NDAs and communications with Scilabs. Scilabs does not usually deal with smaller projects like us. The ability to evaluate a chip for our radio like this is an opportunity that we intend to fully take advantage of. So, if you have the skills and equipment to test this EVM for Phase 4, then this is a very nice board that you can try out. As a result of the evaluations, we will come to a decision about whether a chip like this, which is an ASIC specifically designed for DVB transceive, is a fully qualified alternative to using an FPGA. The ASIC versus FPGA decision is important. One option would be put both part footprints on the board. We would then essentially have a stuff option so that we can do either board, a lower cost unit without, for example, VLSNR using the ASIC, or a higher cost, more full-featured version with an FPGA. Next, Mr. Brain's DVB S2X demodulator coding progress. There's a lot of very good technical updates located at the link in the notes. That is his blog. It is great. Go to his blog and subscribe to the updates and follow it so you will not be disappointed. His code will be in GitLab, G-I-T-L-A-B, until it's working, and then it will be released to his GitHub, which is located here in the links in the notes. There are 10 gigahertz PA possibilities that I need some help reviewing and deciding about, and those PDFs are shown here, and they're also going to be sent to the mailing list. And they'll also be on the GitHub. I'm also looking for updates on the 5 gigahertz RF chain. I'm looking for a schematic and BOM from the group doing that. Let me know. I'm looking for people that are standing around waiting to do something. Let me know. And if you haven't joined AMSAT, TAPR, or ARRL, then please do. These organizations make our project possible. Want to join Phase 4 ground? Well, hey, follow the link in the bumper. See you next week. I'll have lots to report from GNU Radio Conference and TAPR DCC.